Hi guys, so my name is Yukun Patel and we are ML Mavericks. My other teammates are Shubham Kothia and Soumya Bharti. So this is our final project presentation. Which is accessing postcard worthiness in contemporary poetry using NLP, clustering, and semantic retrieval. This project explores how we can use modern AI to evaluate the literary merit of poems, particularly those aligned with postcard price standards. So here our problem statement is traditionally poetry evaluation has been subjective and unstructured. So our goal was to build a modular AI pipeline that could simulate editorial judgment using NLP for feature extraction, then clustering for stylistic grouping, knowledge graphs for structure, FAISS, and Mini-LM for semantic retrieval, and Gemini LLMs for generation and explanation. We curated a benchmark corpus of 28 postcard nominated poems from Iowa Poetry and Poetry Box, um, and two non-nominated contemporary poems from Poetry DB API. And we extracted metadata like title, year, nomination status, and structured all inputs for analysis. So we used Spacey and TextBlock to extract 11 features, including POS ratios, which is noun, verb, adjective, adverb, and then lexical density and type token ratio. Then it also includes polarity and subjectivity score. So the key findings there were pushcart poems had higher lexical richness, balanced POS usage, and more neutral sentiment, which helped us to define a linguistic gold standards. So we will start with pushcart evaluator. First we created a custom pushcart evaluator to calculate how far a poem's features deviate from the gold standard. So um, so the scores were scaled from 0 to 100. Poems were bucketed as high, medium, and low likelihood of pushcart worthiness, and we validated this using radar plots, box plots. As you can see, this is our radar plot, which is sample versus pushcart average, and this is our box plot, which shows our feature distribution by nomination groups. As you can see now, noun verb ratio, noun adjective ratio, adjective adverb ratio, and many more. And this is our score distribution graph. It shows us nominated versus pedestrian poems, and it will show us the probability like 0.80, um, 0.825, 0.850, and we also did calibration graph, calibration curve. So as you can see, it will show predicted probability and versus true probability. And the key results here were score differentiation, surprise high scorers, evaluator robustness, Gemini generated poem evaluation output is also there here. As you can see, this is our output. Now we will move forward to clustering and golden centroid. We applied PCA plus K-means to reveal latent stylistic clusters. So cluster 0 had 75% pushcart poems, uh, which is our golden cluster. We calculated distance to the centroid for each poem. And then several non-nominated poems were closer to the golden centroid than some actual nominees. So they give us a geometric view of the style. Now I will move on to the graphs. Yeah, the knowledge graph. And yeah, we transformed each poem into a POS based graph using Spacy and Network X. Edges were created from syntactic dependencies. Nodes were POS tagged. So we extracted 70 plus subject verb object triplets per poem and applied transitive closure to reveal indirect thematic links. So these graphs formed the basis of our semantic retrieval. So as you can see, this is original dependency graph here, and after that we converted it to transitive closure graph. This is the transitive closure graph, and this one is the stylized SVO graph, which basically is the chain of subject to verb to object. And at last we have a POS type motive subgraph, as you can see. And now we will move on to KG and vector database semantic retrieval. So here, using mini-LM embeddings, we embedded both poem and article triplets. Um, and we queried FAISS vector index with poem triplets, chunk text segments, 5, 10, 20 words. As you can see, chunk size is 5, 10, and 20 words. And the temperature tuning in generative evaluation. So temperature is 0.2 for more deterministic and stylistically accurate, and the temperature is 0.7 also for balanced, and 1.0 for high creativity. And this triplet based query outperformed chunks consistently in cosine similarity. So top matches showed strong alignment with poem themes, identity, loss, and memory. And then, uh, as you can see, we do have graphs also, triplet phrase similarity matrix. This is heat map. Then retrieval source by chunk size. As you can see, we do have a graph of this as well, chunk size versus retrieval count. Then we have cosine similarity of poem triplets by retrieved source. So now we will move on to pushcart worthiness evaluator. So we created pushcart evaluator with clustering. So combining 60% linguistic score, 40% distance to golden centroid. So then we use Gemini to provide interpretive justification for each poem's score. So final scores aligned well with nomination status, and Gemini explanations match model predictions. Now, as you can see, we have plotted graphs as well. This is the graph for final pushcart worthiness score distribution. Uh, the orange ones are for true, and the blue ones are for false. Um, Then we do have a graph of we have box plot of final scores by nomination group, and the key results here are our model scored all nominated poems above 70% and flagged several pedestrian poems as high quality. Then Gemini generated poems typically fell in medium bucket. showing potential but lacking nuance. The final evaluator produced interpretable rankings, reinforcing both statistical and editorial trust. So, for this project, the contributions of our team members were Soumya did data scraping, POS feature engineering, Gemini integration. Subham did clustering, pushcart evaluator, graph constructor, and me, I did FAISS based semantic retrieval, chunking experiments, and retrieval tuning. Then we will move on to discussion. So our system has a wide potential, editorial support, then creative writing tools, then education. So this hybrid AI pipeline combines NLP clustering, symbolic reasoning, and generative interpretation for transparent literary analysis. And we are planning to do in future. We will add rhythms. We will try to add rhythm, rhyme, and phonetic features, expanding to multilingual poetry, integrating human in the loop editorial feedback, and applying to other literary awards like the New Yorker or Poetry Foundation prizes. At last, thank you so much for watching. We hope our work inspires deeper intersections between AI and the humanities. If you want, you can check our code, full report, and in our GitHub. Thank you so much.